Naming ionic compounds. Objectives. Name ionic compounds containing metals that form a single ion. Name ionic compounds containing metals with variable charges. Name ionic compounds containing polyatomic ions. And write the formulas of ionic compounds given their names. Overview. Ionic compounds, metals that form a single ion, metals with variable charges, and polyatomic ions. Naming ionic compounds, metals that form a single ion. When naming ionic compounds made up of two elements, the name of the metal ion is written first, which is the name of the element, magnesium, in this example. Next, the name of the nonmetal ion is obtained by using the first syllable of its element name followed by IDE. In this example, chlorine becomes chloride. In the name of any ionic compound, a space separates the name of the cation and anion. Subscripts are not used. They are understood because the charge of the ions in the compounds balance out. For example, the magnesium has a 2+ charge, while the chlorine has a -1 charge, or a 1- charge. There are two chlorine atoms and they cancel out. Steps to name ionic compounds. For example, KCl. First, we identify the cation and anion, the positive charge and the negative charge. We name the cation by its element name. In this example, it is potassium. Then next, we name the anion by using the first syllable of its element name, followed by IDE. In this example, we have chlorine, which becomes chloride. Finally, we write the name of the cation first and the name of the anion second, potassium chloride. Practice question 1. Write the name of the compound CaS. Here we have the first element is calcium and the second element is sulfur. So writing this element, we will write the first element name as calcium, followed by the second element name with the ending IDE, sulfide. Practice question 2. Write the name of the compound Al2O3. The first element name is the metal. It's written as the element aluminum, followed by the second element name oxygen. The ending is changed to IDE and the name is aluminum oxide. Naming ionic compounds, metals with variable charges. In this example, we have iron 2 chloride and iron 3 chloride. The iron can have multiple charges. The charge of an ion of a representative element, not a transition element, can be obtained from its group number. For example, magnesium found in group 2 has a 2+ charge. However, transition metals are more difficult to determine because they typically form 2 or more positive ions, such as iron, which can be Fe2+ and Fe3+ in some compounds. When a metal can form 2 or more ions, it has a variable charge, and we cannot predict the ionic charge from the group number. For metals that form 2 or more different ions, a naming system is needed to justify the particular cation. This is called the stock system. A Roman numeral that is equal to the charge is placed in parentheses immediately after the name of the metal. Example, Fe2+ is named iron 2 with a 2 in parentheses, while Fe3+ is named iron 3 with a 3 in parentheses. The transition elements zinc, cadmium, or silver do not need a Roman number in parentheses after its name to show its ionic charge, since they only form one type of ions. Steps to name ionic compounds containing metals with variable charges. In this example, we'll examine Cu2O. First, we need to determine the charge of the cation from the anion. In this example, oxygen has a 2- charge. It is found in group 16 and needs 2 more electrons to have a full octet. In this case, we have 2 copper. Each copper should donate a 1+ charge to balance the charges. Next, we name the cation by its element's name, copper, followed by the Roman numeral in parentheses for the charge. In this case, the charge on the copper is 1 plus. Next, we name the anion by using the first syllable of its element name followed by IDE. In this case, the oxygen becomes oxide. Finally, we write the name of the cation first and the name of the anion second. Here we have copper 1 oxide. Key note: copper 1 oxide is written as Cu2O. The 2 does not denote what's in the parenthesis. The 2 just implies how many copper atoms are present. Naming ionic compounds with polyatomic ions. An ionic compound may contain a polyatomic ion as one of its cation or anion. A polyatomic ion is a group of covalently bonded atoms that has an overall ionic charge. In reference table E of the chemistry reference table, we have selected polyatomic ions and their charges. Steps to writing the name of ionic compounds with polyatomic ions. First, we need to identify the cation and polyatomic ion, or the anion. Name the cation using a Roman numeral if needed. In this example, we have magnesium, Mg, which is not a transition element, so we do not need a Roman numeral. Next, we need to identify the polyatomic ion. In reference table E, we look for NO3. It is called nitrate. So now we name the polyatomic ion nitrate. Finally, we write the name of the cation first, then the name of the polyatomic ion second. Here we have MgNO3. It's known as magnesium nitrate. Another example, CuSO4. First, we identify our cation and polyatomic ion. Our cation is copper. Copper is a transition element, therefore it should have more than one oxidation states or charges. So next, we need to look at SO4 to find out what charge our anion, which is polyatomic, has. Looking in reference table E, we can identify that SO4 has a 2- charge. Therefore, the one copper atom must have donated 2 electrons to the sulfate. So we have copper 2 sulfate. Practice question 3. Write the name of the compound FePO4. First, we need to examine reference table E to identify our polyatomic ion. In our formula, we have Fe, which is iron, followed by PO4. PO4 is a polyatomic ion, and it is called phosphate. It has a charge of 3-. There is one atom of iron present, therefore, iron must have donated 3 electrons to the phosphate, which causes iron to have a 3+ charge. So our name of the compound is iron 3-phosphate. Writing formulas of ionic compounds given the name of the compound. In this first example, we have iron 3 oxide. First, we need to identify our cation and anion. The iron 3 indicates iron has a 3+ charge, while oxide indicates the oxygen has a 2- charge. Next, we need to balance our charges. We have 3 iron and we have 2 oxygen. When added together, they must produce a net charge of 0. 2 iron plus 3 oxygen will cancel out. Next, we write the formulas with the cations first and the subscripts to balance the charges in their lowest ratios. Here we have 2 iron and 3 oxygen, Fe2O3. Practice question 4. Here we have iron 2 oxide. First, we identify the cation and anion. We have Fe2+ and O2-. Next, we balance our charges. We have 1 iron reacting with 1 oxygen for a net charge of 0. Next, we write the formula with the cations first and the subscripts to balance the charges in the lowest ratio. Here we have Fe and O. Our final formula is FeO.